Title of this section 5 in the video lecture series, building a simple BCI application using our previous knowledge. So we have learned all about the basics of BCI. Now we have to learn about what is the basics of building a simple BCI application. So in the learning objective, to understand real world BCI applications, what are the different applications available in the BCI, and how to learn the Python libraries, mainly for BCI, MNEs, scikit-learn and OpenBCI libraries, and implement a EEG based cursor control application, and identify challenges in real-time BCI application, and build a final BCI project. So BCI control applications overview, in which there are different types of BCI applications we already learned. In that, mainly we concentrate on smart home control, which is the controlling of lights and appliances, and neuroprosthetics, in which we can control robotic arms with the brain, and communication aids, which will be spelling devices, text to speech, speech to text, like something like that. So gaming and virtual reality in a mind controlled games, entertainment purpose we are using, and visual purpose we can use icons or flowchart for off applications. Visual media we can use icons or a flowchart and for off applications. Python libraries for BCI is many Python we are used for the EEG processing and visualization purpose, and scikit-learn is used for machine learning for classification purpose, and this is the other library we have, OpenBCI Python. This is the real-time EEG data streaming purpose, and diagrams are used to how the libraries interact in a BCI pipeline. So diagram how libraries are interact in a BCI pipeline, that can be used in Python libraries. And the cursor control via EEG, so what is the workflow for the simple project is EEG activation by OpenBCI headset, and pre-processing filter the noise, remove the artifacts, and feature extraction we will already learn about spectral density, where you have to extract that PSD, and classify the this classifier using SVM or LDR to for left or right commands. So there are cursor control means you can cursor control maybe with the left hand or right hand. So we will two outputs at the output side we have a left hand or right hand. What are the output of the cursor is cursor movements are mapped to the GUI, graphical user interface. So cursor control means animation using a Python GUI. It will be a Tinker or PyQt with moving cursor. And the key points is uses the motor imagery left and right hand, and you have to give a real feedback loop, so that whether cursor movement is correct or not. And what are the challenges in real-time BCI is the major problem is signal to noise ratio, which is the eye blinks and muzzle movements, and the delays in processing, and user training also very, very important. It is the adoption time, how much time it will take to train the inputs and getting the output, and the hardware limits. It will also having the different types of limitations on the EEG, etc. cost and channels. Number of channels also very important, and visualization you can comparison table, it will be offline and real time, it is completely different, and you have to match or optimize the results. And what is the final project we can build is build your BCI is the goal is to control a GUI element or button or LED using a EEG signal. So you control the LED using a EEG signal or brain signal. So is the major final project you can adopt. And the templates are pre-processing mode code, it will be used in MNE Python, and classifier is scikit-learn, and simple GUI is the Tinker. Tinker is the simple GUI you can use. And what are the quiz based upon this is your knowledge about this section 5 is which library used for the EEG visualization. MNE Python is used for the visualization purpose. Also input variables also taken by the MNE Python, and pre-processing also is taken by the MNE Python. Name one BCI healthcare applications in neuroprosthetic. We have seen robotic arms, paralyzed patients controlled by brain signals, speech synthesis, and stroke rehabilitation for games. So next, what does GSP stand for? We already discussed a feature extraction method for EEG that maximizes the class availability in motor meter, which is CSP, spatial pattern. how is latency a challenge in BCM? Delays in signal processing. We also see the different challenges in BCM. Is one of the major problem is latency or delay in the filtering as well as the classification steps. So, and what is the conclusion and the next stage is summary is build a BCI demo, learn the key tools, and the future work is hybrid BCI, advanced ML models you have to develop. So this is the future work, and what is the final quote I can quote is the mind is the ultimate interface. So anything you can do in your external world, you have to mind. Your mind is the major part that should be interface, acting as an interface to the real world. So you can build a hybrid BCI based upon this knowledge, basic knowledge, and you can also build a one BCI demo with learned key tools, MNE, Python, OpenBCI, something. We have a Tinkerkit, Tinkerkit, so something like that. So thank you very much.